Good morning and welcome to today's webinar. Before we get started, we would like to go over a few items so you know how to participate in today's event. You may have joined the presentation using your computer speaker system by default. If you would prefer to join over the telephone, just select phone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to today's presenters by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will address them during the presentation or just after the presenters finish speaking. I would now like to introduce Bill Kinkross, VP, Group Publisher and Moderator for today's P&P Optica's webinar.
Hi, I'm Bill Kinkross, Publisher of MeatingPlace, and I'd like to welcome you to today's webinar sponsored by P&P Optica. How a multiple hurdle approach with visual inspection can achieve zero foreign materials in your plant. During today's session, our experts will take a close look at hyperspectral imaging and how it is delivering better inspection outcomes and producing higher quality products. You'll hear about new technologies and how you can get closer to your goal of zero foreign materials using visual inspection. Before introducing our first presenter, we'd like to run a poll among our attendees. And our question is, are you planning to add new equipment to your plant in the next 12 months? Well, unfortunately, I'm not seeing the results of the poll, so hopefully someone will be able to step in and let us know how that poll has turned out. It looks as though 72% said yes and 28% said no. Alexander is Vice President, Sustainability and Government Relations, Belmont Food Group. Doug's experience running food processing operations spans over 36 years in both meat processing and other food processing sectors. Doug joined Premium Brands Holdings as Vice President and General Manager at Ledbetter Foods, and in early 2021 took on the role of Vice President, Sustainability and Government Relations, Belmont Food Group. He is also a member of the Premium Brands ESG Committee. Doug is going to start our webinar today by talking about hyperspectral imaging and why it's uniquely positioned to deliver better inspection outcomes to processors and produces better quality products at the same time. Doug?
And I'll take control. Thank you very much, Bill. I really appreciate the opportunity to see if I can get control of these slides. And I don't yet have control. There we go. Sorry about that, everyone. Thank you very much, everyone, for taking the time to listen to me share my experiences around spectroscopy, the science of it, hyperspectral imaging, artificial intelligence, and my experience with P&P Optica. And again, thanks to Bill for the introduction. Belmont Food Group is a multi-business group within Premium Brands Holdings. We are a company of 99 production facilities across North America with over 10,000 of the best people I've ever worked with in the food industry. I'm very proud to be part of this company and be proud of our sustainability initiatives. And certainly, one of the things that you have to be in, especially the meat industry, is to be bold and to take bold steps. I'm borrowing my boss's quote around boldness has genius power and there's magic to it. I think that's very important to remember when we're talking about this type of advanced technology. Just apologize for the delays in advancing the slides. There we go. So this is a PMP Optica smart imaging system. As you can see, it looks like your standard meat processing plant equipment, shielded from wash down and protected electronics. What's inside, the secret sauce, is what's important. And I often think about, when I think about what's the difference between vision systems and hyperspectral imaging, I get into the talk about spectroscopy and what that means. And to really simplify it, it's like Geordie LaForge's goggles in Star Trek: The Next Generation. So those of you that remember that TV show, you could strap these things on and see in chemicals. So pretty advanced computing power in artificial intelligence, some very powerful instrumentation with hyperspectral imaging wrapped up in a nice shiny package. And so why does this matter? Well, I added up the number of recalls on the FDA website a couple weeks ago for 2021, 233 recalls, some of which were foreign material. And as Mike Tyson says, you know, everybody has a plan until you get punched in the mouth. No one wants to be part of that 48% with less than $9 million for a recall. And certainly no one wants to be in the top 5% with over $100 million in a recall. Something that not only is there a moral and ethical reason, but there's also an economic reason to avoid recalls. So my experience with hyperspectral imaging was about 6 years ago. I was building a couple plants, looking at automated inspection systems. In this case, it was vision systems. And I couldn't figure out why it was able to capture foreign material, but at the same time generate a significant amount of food waste, around 15 to 20%. When we dialed it in for fairly reasonable detection of shape, size, and color, it was over inspecting and creating a significant amount of food waste, which really irritated me. And so I talked to the manufacturers of various imaging systems and tried to find a solution with that nice balance between dialing in the accuracy to capture the foreign material, but at the same time, you know, and not over inspecting, but at the same time, not under inspecting and allowing foreign material to get through, because that was the challenge. We couldn't find that right sweet spot to prevent the toads from getting through with the green stuff, or the piles of waste food products that may get generated when it was over inspecting. So challenging that, I learned a little bit about PMP Optica, and I talked to them about how do we work to reduce our food waste, both worldwide. It's a big problem. In Canada, it's $31 billion a year. In the US, it's more than $100 billion. Worldwide, we waste 1.3 billion tons, roughly $2 trillion of food waste per year. It's a significant problem. So how does a vision system reduce food waste and improve the protection of the consumer by capturing and detecting foreign materials accurately? So I'll talk a little bit about spectroscopy. And those of you who had the privilege of studying chemistry may have taken instrumental methods of analysis. It was my favorite course, and so I apologize for being a bit nerdy about it. But it's the differentiation between older technologies like vision systems and hyperspectral imaging systems is spectroscopy. And the secret sauce in what PMP Optica does and what spectroscopy does is the diffraction grading to precisely separate out all of the energy. So we can see the visual light spectrum. We can't really see ultraviolet well, nor infrared well, but that's the light spectrum that typically cameras work with, visual, infrared, and ultraviolet to a degree with filters. What a diffraction grading does in spectroscopy is it precisely separates about 500 and some odd wavelengths of energy into its individual wavelength of energy. And the chemistry of spectroscopy helps identify the chemical elements in what you're measuring precisely with a very precise wavelength of energy at a specific chemical element: salt, water, fat, protein, plastic, metal, whatever you want to know is there. That precise separation of energy in spectroscopy allows us to see, like Geordie LaForge, in chemistry. And so it can see the salt. Let's say there's crystalline salt going across the top. No, it's not fragments of glass, it's crystallized salt. And those in the cured ham business will recognize that it looks and feels like glass, but it can actually identify what it is and really change the dynamics of the discussion around what foreign material you're dealing with. So simply, energy goes in, very precise energy, excites the electron out of its orbit, and then absorbs some energy. And so that absorbance of energy, the instrument can understand what's absorbed. When the electron falls back into its orbit, it emits energy. It also can understand what that energy that is emitted. And so the detection of the amount of reaction of that very precise energy with the chemical elements, and we're all chemistry, will give you a much more precise understanding of what you're looking at. Not just shape, size, and colors, which are very vague, but the precise differentiation between the different chemical makeup. And that is how it essentially works, is an understanding of how the chemistry works in spectroscopy versus a vision system, which will be able to see what we see, fat, meat, bone, and typically what a standard vision system would see. Spectroscopy or hyperspectral imaging can see complex chemicals instantaneously and precisely. So with the use of artificial intelligence and machine learning, it's a significant advantage to detecting and understanding, identifying specific properties of what you're looking at. So, I skipped a slide. So in this case, there's green plastic foreign material in amongst green spinach, and the chemical imaging system or the smart imaging system from P&P Optica was able to easily and rapidly identify the green stuff that we couldn't see with our own eyes. And if you can't see it with your eyes, you can't see it with a vision system really reliably, particularly not at 2 meters per second, which is generally what a vision system works at. So like this patty right below, you can see the patty. It's difficult to identify the plastic that's on there. A human being may miss this, but certainly the chemical imaging system or smart imaging system that P&P Optica builds can easily identify it. And that's very important, precision and accuracy. It also has the ability, deploying artificial intelligence and machine learning, so big, powerful computer systems built into their technology. This is an early variant we built 7 years ago to understand the chemistry and chemical properties of, in this case, leafy greens, understanding the chlorophyll content and predicting its shelf life, its age, and where it came from, what acreage. So there's some pretty smart folks at P&P Optica that can understand how to teach a machine to learn and take terabytes of data and sift through it incredibly rapidly to understand very precise, unique properties. In this case, chlorophyll, different polyphenol that may be useful in nutraceutical value of leafy greens. So instead of spinach at $6 a package, it might be a nutraceutical at $500 a kg. So in the case of poultry, it could be woody breast identification, the quality of the protein, pork, pale, soft, and exudated pork, PSE. The capabilities of this type of technology are great. And multispectral and hyperspectral literally tear apart the visual light spectrum, ultraviolet and infrared, into incredibly precise nanometer wide and energy units that can give very precise and very accurate chemical readings. So I got itchy fingers this morning. So in this case, the patty with 5 foreign materials on it were able to be identified as meat, cellophane, nitrile, parchment, and copper, a penny, some of which you can see with the naked eye. okay, so you know there's something there and you need to reject it. As a QA manager a long time ago, one of the biggest challenges was when there was a consumer complaint or regulatory complaint about a foreign material that got out and it shouldn't. The investigation was, what is it? You know, is it ferrous? Is it stainless steel? Is it plastic work? We don't have any of that. Identifying the material has a huge advantage rapidly to know where the source is to prevent it or identify its original source. It may not be from your plant. And obviously in the HACCP program helps reduce the food safety risk. And there we go. So again, here's a very clear image of a green form item within leafy greens. It can tell you the temperature. That temperature is the stuff degrading, but it also can identify the foreign material rather quickly and rather precisely, and the human eye can't. In the case of this, these are chicken strips, foreign material. What a camera-based system would see, it may or may not. And frankly, errors are why we want to invest in technology. And so to avoid those errors, a hyperspectral imaging system sees the chemistry of what it's looking at, quickly, rapidly identifies what's acceptable and what we want to sell and what we don't want. And so precisely identifying those is a huge advantage. Having AI systems can teach the instrument to better and better and more precisely identify these foreign materials and detect them. So knowing what it is and identifying that it shouldn't be there are two key factors. And that's really the differentiation, is seeing in chemistry versus our standard visual world. And that's my experience in hyperspectral imaging. So I'd like to thank everybody for taking the time, and if there are questions, the staff here will be able to handle getting them to me. And I will pass that on to, oh, we were going to do a poll. And Bill's muted, so I can just read his lips and share.
Hopefully you can hear me now.
Yes, we can.
Okay, great. Thank you very much, Doug. We are going to do another poll question. The poll question now is, are you considering a vision system as part of your foreign materials detection strategy? And hopefully we will have the results of that in just a moment. And we do. 71% said yes, and 28% said no. So thank you very much for that. I'd like to introduce our next presenter now. It's Amanda Lockheart, Quality Assurance Manager and Process Control Manager at Papillion Foods, Hormel's Foods' newest production facility located in Papillion, Nebraska. Amanda is responsible for implementation and maintenance of food safety, sanitation, and product quality programs in the Papillion facility. Amanda began her career with Hormel Foods in 2006 and has held various roles at the manufacturing plant level in quality management and at the corporate level performing food safety, sanitation, and quality audits of Hormel, their co-manufacturers, and ingredient suppliers facilities as well. She has a Bachelor of Science degree in Animal Sciences and Industry, pre-veterinary option, from Kansas State University. Amanda is going to share Hormel's experience in using a multi-hurdle approach for inspection, including PPO's smart imaging system alongside other technologies. And welcome to you, Amanda.
Okay, thank you, Bill. Hello, everybody. Excited to be here. Today to review how our Hormel Foods plant location in Papillion, Nebraska has incorporated, as Bill said, a vision system into what we refer to as our multiple hurdle approach to foreign material detection and elimination. Get my slides going here. Here we are. So first, I just want to take a step back and introduce you to Hormel Foods, who we are and what we do. You see here, originate, don't imitate. That is a quote from our founder, George A. Hormel. And that is our motto for everything we do, and we incorporate that into operational enhancements as well. Here we are. With 40 of our brands, either number one or number two in their position, in their categories, we have one of the strongest brand portfolios in the industry, whether it's in the center of the store, the deli, refrigerated meats, produce, or frozen. There's not a section of the grocery store that you won't find a Hormel Foods product. We have brands and presence to drive growth through the entire store. And with this in mind, we have a responsibility, especially at the plant level, to do everything in our power to protect our brands and our consumers. So protecting our brands and consumers involves genuine cross-functional team effort. Our cultural beliefs, here shown on this slide, guide our actions as we work together to continuously enhance our operations. I'm not sure that I have control of the slide deck just yet. I'll try that. Here we go. Maybe I do now. All right. So this is just a general trend. Doug spoke to it a little bit. So recalls in our food industry. So as a whole, those have increased. And we continued asking ourselves, what else can we do to mitigate risk to our brands and our consumers? And this led us to using information that was already available to us in 3 areas of focus to facilitate data-driven operational improvement decisions. And those 3 areas of focus were consumer complaints, investigation and reporting, and foreign material risk assessments. Inherent in this kind of analysis are conversations around investment. How much are we willing and able to justify investing in additional prevention and potential recalls for foreign material? What is an appropriate way to track and report savings or cost avoidance, cost prevention towards our ROI? And just think about how much different foreign material events cost on average if you're looking to justify those types of things. And as we analyzed our data from those 3 focused areas, additional questions about our foreign material detection capabilities came to light. Are our processes and production equipment set up for success? What confidence do we have with our detection equipment, and do we truly understand all capabilities and limitations? And what is the best technology at specific steps in our process? We work closely with different vendors, and the concept of a multiple hurdle approach, as is specifically related to foreign material detection, involved from that ongoing data analysis and that process risk assessment. So the next step was asking, what else can we do to detect and remove foreign materials from raw meat materials we are bringing into our facilities to use in our further processing steps? This has the coined term of start clean, stay clean, and we were blessed enough in our Papillion facility to start off right off the bat when we were starting our facility up with that concept in place. And this involves a multiple stage detection system. So you see in this picture, it is showing a metal detector for trim to move through, an X-ray, and then a vision system here. That's the smart imaging system incorporated into the product flow, and product is flowing from left to right in this picture. An additional piece of this multiple hurdle approach was the supplier accountability and feedback for foreign materials that we were detecting. It wasn't intended to be a gotcha moment, but it certainly helps us have accountability at that supplier level to make sure, number one, we're not passing it along for our finished product to have foreign materials in it, but just for an additional feedback to our suppliers for additional corrective and preventive measures to have in place at that level. And I do want to add, because it's important and relevant in this part of the conversation, to note that multiple hurdles and this start clean, stay clean concept are really a holistic approach to foreign material elimination. So overall, our foreign material elimination efforts include a long list of elements. We have facility and equipment design, wood pallet elimination initiatives, team member education and training, pre-operational and operational equipment condition checks, raw material vendor selection criteria, an ongoing contamination risk assessment process, and multiple detection devices throughout our processes. All of this is in an effort to minimize the window of affected product in the event we do encounter a contamination event. So this detection equipment element at the front end of our process is just one of the important pieces of food safety system implemented in our facility. Earlier, I did mention efforts to find the best technology for specific steps in our process. And again, the picture here shows the 3 different systems that we have in place. And that third hurdle is the smart imaging system. And that spectral technology, the smart imaging system uses, it looks at that chemical makeup of materials. And Doug spoke to that just a little bit ago. And what it basically does for us is say, is this meat or is it not meat? Once I've trained it what meat is, it can say, hey, this is not meat. And then it can go on to identify, what is the material, which is also helpful, again, for tracking, recapping, supplier accountability purposes. And one team member is able to perform the functionality verification checks for all 3 pieces of equipment and all of those hurdles in place. Production, maintenance, QA team members who work with and understand the functionality of our metal detectors and X-ray machine are the same team members that we train and involve in understanding the functionality of the smart imaging system. And again, since it is the last step in our multiple hurdle approach, it's the last mechanical line of defense we have to detect and remove foreign materials from the raw meat materials that we are preparing for use in our further processing steps. So we will go ahead and look at an example of what the smart imaging system dashboard shows. Here we are. This is just a view from a camera module in the smart imaging system. It's a helpful tool really to provide some more information about what the system is detecting and kicking out. It only detects on the surface of product. There is no capability of seeing something completely embedded. Kind of if you compare it to the metal detector and X-ray, those can seem embedded materials, but that's where the multiple hurdles and the value of having multiple hurdles in place also comes into play, because you just want to make sure that we've got the best approach overall. But if you look on this slide, you can see there's a really slight hint of a purple circle here, and the smart imaging system uses different colors of circles to identify different materials. So this is a real life example. So if there were other materials on here, and it was a material with a different chemical makeup, it would have a different color of circle. This is a different image from the same camera, and that is just a close-up image to this image here. And it ends up being really a 3x1 millimeter flat sliver of wood, and it ended up being a piece of Chet pallet. So we removed, recovered the piece of meat that kicked out of our kick-out system, and this little guy here was the offender in that scenario there. So again, the sliver of wood would have otherwise gone unnoticed, as would have all of the other examples that are on this slide here. And these are real examples of materials that did bypass any person on the line, any visual inspection we had, metal detection and X-ray on our line. Obviously, most of these we wouldn't expect a metal detector to pick up, but these would have ended up in the products we produce. So again, the earlier mention of that appropriate method of tracking and reporting savings towards ROI. This version of savings is really in the form of cost avoidance, and that we don't end up having to spend the time, the money, and resources downstream in our processes. So if we would have found evidence of those materials, downstream, we could have taken care of it. If not, unfortunately, that could have stood a good chance of having a very poor consumer experience with our products, and even the potential for a foreign material recall. So if you think about how much different foreign material events in your facility, if you're in a facility, costs on average, look at the money that we have sitting on this slide, and really, again, these are only a handful of examples of the smart imaging system kickouts, which was our last line of defense. We use some arbitrary numbers. You see 3 pieces of some soft blue plastic, that's $3,000 there. Let's look at some other pictures. Wood, let's pretend a event downstream might cost you on average $1,500 for an arbitrary number. There's another $3,000 in cost avoidance on this slide here. Cardboard, a couple of pieces there. Rubber and gasket materials, and even if it's not a barium infused or a metal detectable type of gasket, obviously this vision system for the smart imaging system, it'll still say, oh, that's not meat, and it'll kick it out. So a lot of cost avoidance, like in the form of savings on this slide there. So all good real life examples. Some takeaways we have just with our experience of putting the smart imaging system and incorporating that into our inspection line is sanitation. So our friends in sanitation, the belt's going to break at some point in time. So the belt for the camera modules in the smart imaging system know what the belt is. It knows that it's not meat, but it knows to ignore that specific portion of the belt because otherwise it'd be constantly kicking out. But the broken section of the belt will also register as not meat. So you need some extra belt links on hand so you can make sure that we keep that system up and running as much as possible and as quickly as possible when a piece of belt section breaks. So the space, the layout we saw in the earlier slide, it's about 80 feet long for that multiple hurdle approach, and there are different layouts, obviously, that different plants can facilitate in terms of fitting all of that equipment into maybe a smaller footprint. Engineering friends can help with that. Training period and availability of on-site resources. So I mentioned, hey, the same people who understand and can perform the functionality checks for the X-ray and the metal detector, that can be the same people. However, you do need some resources in the terms of personnel to be the points of contact for the different equipment validation steps. It takes a lot of passes through to make sure that the equipment learns what different form materials are. We've used a lot of times the analogy of a small child. You can't stick the child in the corner and just tell it something once and expect that to catch on. It definitely takes several iterations and lots of practice for the machine to know what it's looking at. It still recognizes it as not meat, but if you're wanting to tune in and hone in on what the type of material is, that takes additional practice. And those camera module modeling learns, again, that repetition there. The resources for data recapping need to be there as you're continuing to build your tables, I'll call them, in the background. And the good news is once you build some tables with certain types of meat, then you can transfer that table information to a different machine in your facility if you have one. So basically optimizing performance, that's kind of that performance optimization piece for additional resources. And so you'll get out of it what you put into it, as with any equipment, but definitely excited about our multiple hurdle approach that we've been able to act on and install and invest in here in Papillion at the Papillion Foods facility. So thank you for everybody for your time and listening to what we've got in place here.
Thank you, Amanda. We're going to bring back Doug Alexander and open it up for questions from our audience. If you haven't had a chance already, if you look at the GoToWebinar control panel, you'll see a questions tab, and you can type your questions in there, and then we will be asking questions from there. So the first question I have, and either one of you can take this, what are the capacities on these systems, meaning pounds per hour? This particular person said they are running chicken tenders and breasts. Doug?
Well, I can certainly, I mean, it depends on the calibration. I think that's really a question the designers at P&P Optica can answer. Amanda could probably talk to, if it's not proprietary, how many pounds they process through, but each individual parameter, so in other words, chicken breast versus pork chops, will have a different calibration curve. It will have a different speed interaction of the belt. At the end of the day, the smarter the system is, the faster it can run. So a more precise detection not only reduces labor, so if you have a problem in your plant and you're throwing human beings at it, they don't exist. We don't have as much labor as we used to have. And that tends to slow the line down. When you have to look at the product more carefully, you typically will slow the line down. And a faster, smarter system, especially one deploying artificial intelligence, will more rapidly identify the foreign material and more confidently. So I would say, if anything, not having human intervention will increase your output, and having a more precise and powerful computing system will increase your output. I'm not sure what Amanda wants to add to that she's allowed to.
Yeah, simply put, it is something that you put kind of in the scope of the project as you're putting it together for that deliverance from the vendor. So in our system, that vision system is not our bottleneck. So it is spec'd at, arbitrary 30,000 pounds per hour, but we only deliver maybe 15,000 pounds per hour to it because of an upstream piece of equipment for us. So we have not been able to challenge it at that performance spec, but it is a performance criteria that would go into any agreement that you have.
Okay, thank you both. This should be an easy one. What company is the smart imaging system from?
You mean P&P Optica?
Well, I think that could be the answer there, Doug. Thanks. Next question. What is the effectiveness of removing foreign materials versus good product in the reject stream?
Amanda, you want to feel this? I'll talk about old experience.
Actually, I think you kind of already spoke to that, Doug, a little bit ago. The more practice it has, the more confident the more confidently the machine removes and detects real foreign material. At first, you'll experience some shadows, ice crystals, those types of things. It'll create some false rejects, and then you start to kind of dial it back with practice and teaching it. Say, oh, that's an ice crystal, I don't want you to kick that out. Or, oh, that's a shadow, I don't want you to kick that out. So that's working closely with the vendor for that piece of it. But again, repetition is key in building that artificial intelligence into the system.
In my experience, similarly, in vision systems, essentially, we were told it is what it is. This is as good as it's going to be able to do, because there's a limited computing power built in, and there's a limited ability to detect and understand foreign material. Whereas having advanced algorithms and artificial intelligence and an incredibly sensitive instrument to detect, and with powerful computing, you have the ability to get better and better and better at detecting foreign material. You have less and less false positives or over inspection rather than under inspection. And that's been my experience in the leafy greens business. Was those were real numbers, 15 to 20% waste by over inspecting. And then by under inspecting, stuff got through into the package that shouldn't have, both at the speeds at which the lines were running, and no one wants to slow down their lines. So I think the advantage in being able to continuously learn continues to reduce that false reject and pass through of foreign material. So it continues to get better.
Great. On to the next question. The material products tested, do they need to be in one layer? And is it possible to check them in water?
But
Amy?
carry on, Amanda, sorry.
Yeah, you do need to present it in, a layer. If two pieces of meat are sandwiched together, you're just not going to get any type of inspection on those two sandwiched areas unless you have a waterfall application within the system itself. Obviously, those two pieces of meat could end up separating. But again, then there's lack of control over that process where you don't know if you are inspecting the same side of that piece of meat again, or if it happened to land to where both of the sides, land face up to the next camera module. So it is best to have the thinnest stream that you can, because it will not look through that. The smart imaging system won't look through anything. It's just what's visible to the camera.
So P&P Optica works with machine design companies that will customize the in-feed and in-process design of the system. So if you have to flip the material over to see top and bottom, if you have to have underside inspection as well as above inspection, which some cascading systems have, where it falls through two camera systems, through inspection systems. It can also have smearing systems that go through a plate to better identify, sausage filling and look for foreign materials. So they've had a great deal of experience in manipulating the product, but Amanda's right. It has to be exposed on the upper surface or a surface that the image system can see. Foreign material like, bone cartilage is very difficult to detect within anything, whether it be X-ray or metal. This is just another tool to add more precise material detection. And yeah, you have to find a way to make it within the aperture of the instrument.
Okay, great. Amanda said her technology was surface only, but I missed Doug's. Is it surface only as well?
Well, in the application that we were working on, yes, it was, but we manipulated the product, flipped it over, separated it by speeding it up. But yes, it was surface only. The chemistry and the chemical parameters that we were measuring, like the chlorophyll, to determine qualitative and value of the product, was the chemistry, which does have an interaction not just on the surface, but of the material. But it doesn't penetrate through like an X-ray would all the way through the material.
Okay, thank you. This is a little bit of a follow-up to the question a little bit ago. How long did it take the system to hone in to get a targeted speed and find the foreign material that you're looking for?
Amanda's thinking.
Yes, I'm counting months, I suppose. Now, the honing in was really pulling the system back from the over rejection piece of it. So really it was put in place in the fall of 2021. And I would say we had a good handle on what the system would deliver, and more comfortable with what we were considering a false reject rate the summer of 22. So that's what I mean by iterations, and resources available too. So the more resources you have available to continuously work through, the faster it will be. It was obviously, I think Doug spoke to labor, it was a labor shortage of resources there that where maybe a month or two would pass, we were like, okay, we've got to get back to this to teach this to ignore the shadows or those types of things. So for us, it might not be a typical scenario, but it took a good maybe 10 months with a couple of months in between there with no activity, and we just let it roll, and we'd over inspect and then visually inspect and reintroduce as the line allowed us to.
I think it's a matter of the complexity of the materials coming in. So having the ability and the computing power to continuously learn and have the machine learn, to have interaction between technicians and the challenges that you may be faced. This equipment is capable of continuing to refine and narrow the precision. So you might start in 2 weeks, we'll say 95% confidence of specific material. So if you have a specific problem, it's able to identify it rapidly and then repetitively and then more and more and more precisely over time. It may take months to get it to 99+%. And the folks at P&P would kill me if I were to say 100%, but they've had experiences that over time, it continues to get closer and closer and closer to 100%, but it really depends on the complexity of the materials inbound as well as what form material is. But the neat thing is, once it learns the baseline of what it's used to, anything that's unusual, it will easily and precisely be able to determine. So if it doesn't fit the algorithm that it's learned, it'll detect it very quickly and easily. So if it shouldn't be there, if it's foreign material, it'll identify it fairly readily, rather than just a different image on the screen.
All right. Does product temperature affect the vision system? Meaning, can we put frozen material past it?
Like the question every metal detection company hears, what's the temperature? Is it frozen or is it fresh? It depends on the crystals and the magnetic signature. Amanda, I don't know what your experience has been with it, but I would imagine the temperature is not really relevant once you build a calibration.
Yeah, that's correct. Our experience has been the only reason the temperature mattered was because we have ice crystals, so some of our materials are just diced, tempered, so still partially frozen blocks, little diced blocks of meat. And so it wasn't so much the temperature that was relevant, it was more that those ice crystals would trigger a false reject. Okay. And we had to train that out of it.
The couple more questions here. The system only identifies foreign materials when on top of the product, correct? If the foreign material is beneath the raw material, it would not be detected. And that is, of course, the question.
Yes, it would be with any instrument other than maybe a metal detector, so a magnetic signature change or an X-ray, which would be based on density, and hence why Amanda's company deploys a multi-hurdle. It's not a one-shot, one-kill approach. You have to have that multi-hurdle approach to capture those embedded materials. The limitation, as we all know in metal detection, is one size in magnetic signature, and in X-ray, it's density. So the more stages you add to it, the more reliable your inspection system is. You should be very proud of your investment in your facility, Amanda. That's quite impressive.
Yeah, thank you. I mean, that is why we just designed kind of the waterfall piece to it, with the intent of trying to turn the product as best we can and look on that, that underside. What would have been the underside for one camera module becomes the top side for the next camera module in line.
Couple more. Is the equipment for only whole muscle products, or is it for whole muscle products only, I guess would be a better way of saying that?
Necessarily, you can have trim going through there. Yeah, he used spinach, so you can have trim going through there. Again, it's just a matter of, we'll call them touchers, or whatever we want to say. If something is mashed together and it's not visible to the camera modules, it's not going to see it. Again, multiple hurdles are key there. It's not just a one-stop shop. They all work together, all the systems.
Yeah, there's applications on ground meats or ground powders products. It's just manipulating whatever you're measuring to present it in front of the inspection system so that it can see the surface. Doesn't matter what it is.
So what you're saying, Doug, is spinach is not whole muscle meat?
No, it's not. It's definitely not, and you can't make it into whole muscle meat. For those of you that know me on other social media platforms, okay. I'm not a big fan of that stuff. So there was a question about water. Can it inspect something within water? It depends on the turbidity of the water. If it's clear, there has been spectroscopy used to measure BOD, COD, and fats, oils, and grease in water. There are companies that provide that. So technically, yes, it depends on how well you can see through it. That would be a very interesting application of hyperspectral imaging.
Thanks, Doug. We've got time for just one last question. This question's going to go to Amanda. What percent increase in finding foreign materials on site versus percent decrease in consumer complaints did you see after implementing and calibrating the system?
I don't have the stats in front of me. We're also a new facility, so have the ability. So we don't have a lot of historic information to compare to. But I can say from previous experience in other facilities, we are it's in terms of supplier notifications. It's at least twice as many supplier notifications for what we find in materials as there was before, because we were running for maybe 7 or 8 months before we got the system online, and we at least doubled our supplier notifications for materials we were finding.
Okay. Once again, I'd like to thank our speakers today, Amanda Lockhart and Doug Alexander, and also P&P Optica for bringing this content to our audience. I'd like to thank all of you for joining us today, and I'd like to also remind you to please take the survey after the webinar. And if you're interested in learning more about visual inspection options, please contact Jennifer Gingrich from P&P Optica. Her email address is sales@ppo.ca. So on behalf of P&P Optica, we'd like to thank you for attending today.